welcome you, sir. Welcome, Dr. Dinesh Kumar, sir.
Thank you, sir.
Now I hand over to Sarangapani, sir.
Now I call upon Mr. S. Saranakumar, Assistant Professor, to introduce our eminent chief person.
Thank you, sir. Very good afternoon to one and all present here. Dr. Dinesh Kumar is currently working as an assistant professor in National Institute of Technology, Srinagar, since March 2021. He did his postdoctoral research fellowship in Department of Mechanical Engineering at Indian Institute of Technology, Guwahati, from 2020 to 2021. He obtained his PhD degree in 2019 from National Institute of Technology, Trichy. He did his Master of Engineering Production in PSG College of Technology, Coimbatore, on 2014. He did his Bachelor of Engineering Mechanical in Southern College of Engineering, Trichy, on 2012. He has applied one patent and published 10 journals to his credit in SI and Scopus Index journals, and also contributed 3 book chapters in metal additive manufacturing and friction stir welding published by Springer. He is an all-rounder with extraordinary leadership and teaming skill with multiple achievements in curricular, sports, co-curricular, and extracurricular activities. With these words, I would like to invite Dr. Dinesh Kumar to take over the session.
Thank you, sir. Thank you so much for the nice intro. Vanakkam, everyone. Is there anyone who doesn't understand Tamil in this group? Is there anyone who has a problem in understanding Tamil? So that I can go complete in English, or is there anyone who don't understand Tamil in this group?
No, sir.
No, everyone understand, right? Cool.
Yeah.
Nandri, மிக்க நன்றி. நான் தமிழ்ல பேசுறதுக்கு எனக்கும் கொஞ்சம் நல்ல சந்தோஷமா இருக்கும், அவ்வளவுதான்.
Bilingual is best. Good, Dinesh. Good. We're always like both the language. Thank you, Dinesh.
Yeah, thank you, sir. Thank you so much for that. Alright, Vanakkam, let me begin my session on the topic friction stir welding of light metal aluminum alloys for aerospace application. So I'll be discussing mostly on aluminum and magnesium alloys. What are the different aspects I was working with ISRO or IIT or NIT. So I'll try to give a glimpse over it. So I had a better introduction from the session presenter. Let me introduce about my college. I'm from NIT Srinagar, where this is our campus, what is being located in Srinagar, where it was like one of 17 RAC which was established in 1960. And to the beauty of the campus is where you have seen behind what we have the Dal Lake, famous Dal Lake, which is just behind the campus over here. And there is a hazardous ball train which is said to be the beauty of this Srinagar. And of course, this is how our campus looked when I joined here. This was the photo clicked by me when I joined here in March. So this is the beauty of our campus. Moving on to the session, let me have a small glimpse. Welding அப்படினா என்ன அப்படிங்கிறது எனக்கு நான் எப்படி புரிஞ்சுட்டேன் அப்படிங்கறத ஸ்டார்ட் பண்ணிட்டு I'll directly go on with friction welding process. Though there are too many welding process, why this particular process is particularly unique when compared to other process அப்படிங்கறதையும் சேர்த்து will see them. So what is welding அப்படிங்கறதுல it's a process of joining, right? ஏதோ ரெண்டு மெட்டீரியல் இருக்கு, we are going to join it. எப்படி ஜாயின் பண்ணுவாங்க? with the application of heat or pressure. ஒண்ணு மெல்ட் பண்ணி ஹீட் பண்ணுவாங்க, இல்ல pressure apply பண்ணி they will try to forge. That is what is called as forge welding. So கடைசியா எப்படி டிஃபைன் பண்ணிருப்பாங்க அப்படின்னா, welding is a process of joining similar or dissimilar material by the application of either heat or pressure without applying filler material. So இதுதான் வந்து பேசிக்கா வெல்டிங் வந்து இத பண்ணணும். So இத வச்சு நிறைய டெக்னாலஜி டெவலப் ஆயிடுச்சு. இட்ஸ் லைக் பேசிக் வெல்டிங் ப்ராசஸ் works on the principle of short circuiting, and what we are going to study today, it is completely on mechanical automation. Like you don't have anything related to current or electricity. There is a small friction which is needed to create energy. இது சொல்லணும்னா earlier days நம்ம எப்படி ஒரு ரெண்டு கல்லையும் உரசி ஃபயர் கிரியேட் பண்ணுவோம், சேம் ப்ராசஸ் இங்க என்ன பண்றாங்கன்னா பிளாஸ்டிக் டிஃபார்மேஷன், தட் இஸ் வாட் இஸ் கோயிங் டு ஹேப்பன் இன் FSW process. So about history, Indian history about welding அப்படின்னு பாத்தீங்கன்னா எத்தனை பேருக்கு இது தெரியும் அப்படின்னு I'm not sure. So this is something which was erected in Delhi in 310 AD. இதுதான் இந்தியாவுக்கு first welding structure which was introduced in India. இதுக்கு முன்னாடி welding அப்படிங்கிற concept was nowhere in India. I'm speaking only about India. So அதுக்கு முன்னாடி வந்து இந்தியாவுக்கு வந்து வெல்டிங் அப்படிங்கிற கான்செப்டே தெரியாது. பட் இந்த இது எரெக்ட் பண்ணல, they need to have some joints which is to be actually molded by welding. That's how actually welding was introduced to India. அதுக்கப்புறம் என்ன ஆச்சு அப்படின்னா, அஃப்கோர்ஸ் லைக் there should be some evolution over a period of time. என்ன நடக்குது, ஓகே some forging technique was used, like it was heated, it was screwed and it was joining. அதுக்கப்புறம் there was introduction of gas welding, like oxyacetylene gas or normal what you have manual metal arc welding, அதெல்லாம் வந்துச்சு. But earlier it was started with Goldman Smith, like அந்த நம்ம கொல்லுப்பட்டறையில் அடிக்கிற, that was the first welding technique or joining technique which was being introduced. Right, okay, there was an evolution, then there should be evolution to have these many process. Like welding அப்படின்னு பாத்தீங்கன்னா it is not about whatever we know solid state welding or fusion welding. அதுல பாத்தீங்கன்னா we have like 100 plus components. If you take about TIG welding, there are different series of TIG welding. MIG welding different series, SMAW or FA flex core rod welding or even when you go for solid state welding, ultrasonic other steps or I think some disturbance I'm getting, sorry. நிறைய வெல்டிங் ப்ராசஸ் இருக்கு. இது எப்ப ரெவல்யூஷன் இட் ஸ்டார்ட் இன் தி சென்ஸ் during the World War I and II. அப்போ there was only two particular thing which was like machining was the only criteria which was completely used to manufacture all the component which is to be manufactured. So suppose like இப்போ இந்த பென் எடுத்துக்கிட்டேன்னு வச்சுங்களேன், இதை எப்படி மேனுஃபேக்சர் பண்ணிருக்காங்க அப்படின்னா, ஃபர்ஸ்ட் இதை மட்டும் தனியா மிஷின் பண்ணிட்டாங்க, அப்புறம் இந்த டிப், அதே மாதிரி இந்த கேப், அதுக்கப்புறம் இந்த மாடல், அதுக்கப்புறம் இந்த மாடல். ஸோ இதெல்லாம் மேனுஃபேக்சர் பண்ணி அதுக்கப்புறம் அசம்பிள் பண்ணிட்டாங்க. பட் ஈச் அண்ட் எவ்ரி திங் அந்த மிஷின் பண்ணி மேனுஃபேக்சர் பண்ணி வர்றதுக்கு வந்து இட் வாஸ் டேக்கிங் லாட் ஆஃப் டைம், வேர் தே வேர் நாட் கெட்டிங் இனஃப் டைம் டு சர்வைவ், சஸ்டெயின். தே டோன்ட் ஹாவ் இனஃப் டைம் டு சர்வைவ் தேர் லைஃப், சஸ்டெயின் தேர் லைஃப். இன்னொருத்தான் இருக்கான், வர்றான், அடிக்கிறான், போயிடுறான். Then they started introducing this the revolution in welding happened during World War I and II. அப்போ வந்து there were lot of material requirement. வேற வழியே இல்ல, உயிர் வாழணும் அப்படின்னா we should have better equipment than our opponent. அப்போ they introduced this welding technique during World War I and II, which was making a huge revolution, because whatever you machined for a week, it was done using welding process within a day time. ஒரு 4 பேர் சேர்ந்து ஒரு 4 காம்பனன்ட் மிஷின் பண்றது, ஒரு இடத்துல அசெம்பிள் பண்ணி வெல்ட் பண்ணி it was giving the output. So that's how the revolution happens. Again types பாத்தீங்கன்னா obviously நிறைய welding process இருக்கு. Basically இது மட்டும் தான் அப்படின்னு பாத்தீங்கன்னா இல்ல, like still I have given very few in here. இதை தாண்டி நிறைய வெல்டிங் ப்ராசஸ், தட்ஸ் வாட் ஐ வாஸ் சேயிங். டுடே இட் வாஸ் லிஸ்டட் அரௌண்ட் 120 plus வெல்டிங் ப்ராசஸ் which is available with different process sequence. நீங்க டிக் எடுத்துட்டீங்கன்னாவே அதுலயே நிறைய இருக்கு. இப்போ we have moved on to the advanced stage, cold metal transfer, CMT or hyper fill or tandem MIG, அது மாதிரிலாம் நிறைய ப்ராசஸ் வந்து இண்டஸ்ட்ரி அடாப்ட் பண்ண ஆரம்பிச்சிட்டாங்க. So we got plenty of welding process, and the topic for the discussion will be only based on solid state welding process, exclusively on friction state welding process. Solid state welding process, as I said before, நம்ம கொல்லுப்பட்டறையில் அடிக்கிற மாதிரி, it's a Goldman Smith where they heated something and they kept it together, they applied some force and both were getting fused together after solidification or after cooling, both were making a bonding. That's how the welding was happening earlier. அதை வச்சு what it was created is this friction welding was then further technology. இது என்ன பண்ணுவாங்க அப்படின்னா, mostly the dissimilar material which cannot be welded together, they were using this particular process called as friction welding. Maybe இதை நீங்க எங்க பார்த்திருக்கலாம் அப்படின்னா, if you have gone to this workshop where you have carbide tooltip which are being brassed right now, where earlier during this particular operation the tooltip was actually kept idle and the rod was like mild steel or HSS wall rotated and both were closed together, and at a point like when both were getting heated up, it was fused together. That's how like this friction welding concept was working. But our process, like what we will discuss today, is completely on friction stir welding. In the friction stir welding, how it is going to differ from friction welding? Friction stir welding is just a stir technology which uses mechanical force or a frictional force to join two materials. So the best advantage of this particular process is this do not consider about what is the material being used. This do not consider about what is the tool being used. This will not consider about what is the aspect, like in the ratio in the thickness. Now even 100 thickness can be done with two pass, like where single pass can be done with even 50 one pass is capable of even welding 50 so இதுல எந்த கன்ஸ்ட்ரெயின்மே கிடையாது. If you go for manual metal arc welding or TIG welding or MIG welding, அங்க என்ன பிரச்சனை இருக்கும் அப்படின்னு பாத்தீங்கன்னா, you have to fill the material, like layer by layer you have to fill the material, and over the stage you have to go on. That is what we called as wire arc additive manufacturing. Morning, like Vimalan would have informed me, given you a better introduction about what is wire arc additive manufacturing. So இதெல்லாம் என்ன advantage and disadvantage அப்படின்னு பாத்தீங்கன்னா, everything has its own advantage and disadvantage, but this process is completely making a single layer process where you don't have particular thing called as highly heat affected zone. இந்த ப்ராசஸ் இருக்கையில என்ன ஒரு ரீஜன் ஆகும்னா, இப்போ நீங்க வெல்டிங் இது பண்ணல, you have a core like this, you have to fill from here, then here, then here, then here. இந்த இடத்துல என்ன ப்ராப்ளம் வரும் அப்படின்னு பாத்தீங்கன்னா, there is a inter bonding between this particular layer and this particular layer. Yeah, I'll use screen. So there is a bonding between this particular layer and this particular layer, where again the layer is getting heated up. First process பண்ணிட்டீங்க, again the layer over here is getting solid, melted and again getting solidified. அங்க வந்து ரெண்டு process of recrystallization நடக்கும், where your crystal structure is completely going to be regenerated or recreated, which has both positive as well as negative defect. But this particular process what we use here is FSW process, where you will have a single setup through which you will be going for a single pass. இதுல ஒரு tool material இருக்கும், with the tool you will be joining the complete workpiece in a single pass. அதுதான் இதுல இருக்க ஒரு difference, because here the grain refinement or the grain structure formation will be completely almost uniform throughout the process sequence. அது வந்து the beauty of this particular process is attributed. And one more uniqueness is, this particular FSW process is the only process which is having a definite zone called as thermomechanically affected region, where other welding process, if you look into it, you will have only this particular thing where you have a base material, then heat affected zone, then weld nugget. So weld nugget, heat affected zone, then base material. This particular process has one more beauty, which is giving rise to another domain called as thermomechanically affected zone. எங்க இருந்து சார் இந்த thermomechanically affected zone அப்படிங்கிறது வருது அப்படின்னு பார்த்தீங்கன்னா, like there is a thermal barrier which is being created due to the introduction of your tool onto the workpiece. Then there is a mechanical force, there is a mechanical action which is triggering the process. So when mechanical and thermal effect are going to have a impact at a particular point, there it generates a new process or new terminology called as thermomechanically affected zone, which is the uniqueness of this friction stir welding process. So throughout this lecture I'll be discussing few things. What are the things journey what we gone through in ISRO in welding of aluminum alloys or magnesium aluminum transition joints, and how this is going to be applicable. அது மட்டும் தான் இந்த throughout the process இருக்க போகுது, right? So this was the microstructure what we obtained during 2219. Yeah, aluminum alloy 2219 A 2219. This you will not get it anywhere. Like you can, if you want to work on this particular material, you can collaborate with ISRO or DRDO. So they have this particular material. In the material oda beauty enna appdin kettingna, the ductile to brittle transaction appdin solluvaanga. When there is an exposure of change in temperature, this particular material has a beauty to get better ductile to brittle transaction at a wide range of this is about, I just want to show what are the machines I worked on. This machine I worked on in NIT Trichy. We have a specialized FSW machine, and the same machine is available in ISRO as well. And those who want to work on FSW, it is not required, like only you have to go with this particular thing. The customized CNC milling machine can also be used as a FSW machine, Right. The major joining process in this particular process is like other welding process. You can go for plenty of operation, either it is butt welding or lap welding, where this process of making layer over layer given rise to friction stir additive manufacturing (FSAM). This is a new trending technology which is happening in this. It can also create many profile. It is not this can be only used for creating butt joints. This is also applicable for many joints based on the profile what you require, right? So if you consider about what will be the major parameters in this particular thing, obviously when you go for welding, you have current or voltage which is being controlled, the standoff distance or arc distance which is to be maintained, and the speed, obviously the travel speed in which the welding is going to happen. If it is going to be laser, what is the laser source if you are going to use, or what is the focal point you are going to have. So you have plenty of parameters which is going to decide what is the welding impact on your particular material. And same way, this particular sequence, this particular FSW also has some parameters which is attained to it. They are generally rotational speed, where the tool will be rotating at a particular RPM. Then comes your travel speed. After rotating, the tools moves out with a particular travel speed, maybe say 100 mm per minute or 200 mm per minute. It keeps on rotating and moving. It keeps on rotating and moving. Then tool profile. So if you consider about tool profile, there are plenty of tool profile. The best thing is said to be tri-floated, which is quite costly and quite critical in manufacturing, but still we are quite comfortable with triangular or threaded tools. That is also giving better efficiency. Then having tool tilt angle. In this, what is the tool tilt angle is whenever the process is moving on, the friction will be some completely towards, like when you have a two component, if it is completely in 0 degree, it makes a complete mating which is going to have lot of friction, and it is not going to be that much effective. So what we do here is the tool will be tilted at a particular angle. Say this is the tool which is at 0 degree, and we'll make that tool tilt into around 1 or 2 degree, so that the packing will be there. Still there, the friction force will be eliminated because there is no friction which is happening throughout the process. A base slide, it's like a board structure, the aerodynamic shape where it slides at the front and compacts at the back. So other we have one more parameter called as tool tilt angle. Then plunge depth. This plunge depth you have some particular parameters where you want to do welding till this, and your shoulder will be resting over here. So what should be the plunge depth based on your material thickness? So that is also going to be defined. The material thickness you will be having different plunge depth which is to be different. Then initial heating time. What is this initial heating time, sir? You are going to plasticize the material and fuse it. You are not going to completely melt it. You are just going to plasticize the material. Plasticize you are going to introduce a tool, and a heat is to be generated by the frictional force which is being created, and that frictional force is going to create a semi-solid metal layers through the process. And the time required for creating that semi-solid metal layers in the process is what is called as initial heating time. So with that, we'll have like clear understanding what is this, how much it is required, and this can also give you a better thing. And load applied. In the load applied, now we have moved with bobbin tools or supported things. This load applied the compact force which is to be supplied from the tool, that has to be completely compressed, and the material, it is going to reform the material. Whatever the material it is going to reform the material. The original bonding is to be disturbed. If the original bonding is getting disturbed, it is not melted and recrystallized, so that it will have still more closer grinds. This is actually reassembling. Crush பண்ணி இருக்கதை நம்ம எடுத்து விட்டோம்னா எப்படி இருக்கும்? So it is going to get distracted. Soan pabriக்கும் பஞ்சு மிட்டாய்க்கும் என்ன டிஃபரன்ஸ் இருக்கோ அதை தான் இதுல நம்ம பண்ண போறோம். When you have soan papri, like it's a compressed form of panju mithai. So where you will have a small column, but when that is taken into things, same thing is going to happen here. நம்ம இங்க recrystallize பண்ணையில என்ன ஆகும் அப்படின்னா, இருக்க மெட்டீரியலை நம்ம மறுபடியும் வந்து ரிவைண்ட் பண்ணையில என்ன ஆகும், atomic or the structural calamity will be completely changing. Appo we have to apply some load from the top in order to get its original state. ஏன்னா இப்படி சும்மா இது பண்ணிட்டு போனோம்னா the mixture is going to have unstable or unsustained. In order to avoid that, we have to give particular load that is going to create a original. So retaining 100% welding efficiency is not at all feasible. If anyone say I am obtaining 100% efficiency by FSW, directly you can say they are blabbering, because this is not going to be a reality. It is possible when you go for post welding heat treatment. When you go for post welding heat treatment, this obtaining 100% welding efficiency is possible, but still you can get up to 94 to 95% based on controlling all these process parameters. If you could able to control all this process parameter in a proper way, the best possible parameter will be around 94 to 95, where when you compare with fusion welding process, in fusion welding, the minimum eligibility to qualify as a better welding is 115%, where if your parent material strength is 100 megapascal, after welding you should minimum get 115 megapascal as your output. This is the minimum requirement in fusion welding process, but in solid state welding process or FSW, there is no chance of getting 100% efficiency. Okay, இது 100% efficient இல்ல, அப்புறம் எதுக்கு சார் இந்த ப்ராசஸ் யூஸ் பண்ணும்? What is the beauty on using this particular process, that too in ISRO or NASA? What is the beauty on using this process, right? There is few material which is named as non-weldable alloy or non-weldable materials which cannot be welded by any of the process. அதுக்கு வந்து electrical conductivity இருக்காது, அதுக்கு வந்து higher reflectivity இருக்கும், so that cannot be taken with electron beam welding or laser beam welding as well, because due to lot of reflectivity it will not be feasible. அதுக்கப்புறம் the conductivity also will be very poor, so that even if you go for coating, the welding will not be proper. இது மாதிரி material which is not good for welding, it is, they are said to be non-weldable grades. There are too many things. இப்போ create பண்ற inconels இருக்கட்டும், alloys இருக்கட்டும், there are too many material which has a specific property. They are completely electrical resistive. அப்படி இருக்க மெட்டீரியல்க்குலாம் you have to depend on a particular process. See, if it is going to be thin sheets, you can go with ultrasonic welding, obviously, like that don't have anything. It provides some sinusoidal rays where your transducer is going to convert your mechanical, ultrasonic waves into mechanical force, and that mechanical force will vibrate at a particular point, and the heat will be generated, both will be clamped. Adu vandu if it is going to be thin sheet. When you are going for a bigger component for welding, which are completely non-weldable grades, this is found to be the better solution. And this process gives you where you can join any of the material apart from what is the characteristic, what is the feature, you can join it completely without any problem in this. But only deficiency of this process is it will not get any time 100% efficiency unless until some post weld heat treatment is happening. And one more defect in this process is you will have end hole generation at the end of the process due to the impression of the tool. And this thing can be obtained by post weld heat treatment, and this thing can be obtained by retrating tool. There is some tool which is called as retrating tool. I'll just show everything in future. So that particular tool costs around 2 lakhs. So we Indians are not affordable for that particular thing, where each tool you will go for 2 lakhs. So நம்மள்ட்ட இருக்க டூல்ல வந்து we will have always this end hole formation. That also like we'll use some juga technique, ஏதாவது ஒரு இது பண்ணி we are eliminating that as well. So I'll explain the complete process and what is the journey what I faced in ISRO completely. So these are the different tool profile, mostly that PCBN like boron nitrate, like polycrystalline boron nitrate is being used, and tungsten based and tool steel. And for aluminum or magnesium, this is more than enough. When you go for titanium based welding, you have to go for tungsten based. Like when you go for inconels or super alloys, you have to depend on this PCBN, polycrystalline boron nitrate tools. These are the tools available, but this will be quite costly. In the tool we did for around 6,000 per tool, and in the tool it will be quite more higher because this is completely sintered and produced. Profile pathina normally we are okay with this profile. normal welding போகணும்னா this profile is more than enough. And if you want a better quality, you can go for this threaded. எப்படி வந்து threaded will have better efficiency this அப்படின்னு கேட்டீங்கன்னா, I'll give you one more example. நம்ம வீட்டுல மத்து இருக்கும் தெரியுமா, லைக் மோர் கடையிற மத்துல வந்து பாத்தீங்கன்னா இட் வாஸ் லைக் ஒன்னு வந்து பிளாட்டா இருக்கும், வேர் வென் யூ டூ சம்திங் யூ வில் நாட் ஹாவ் மேக்ஸிமம் ஃபிரிக்ஷன். பட் அதுவே இந்த இப்படி ஒரு மத்து இருக்கும், ஆக்சுவலா டீத் மாதிரி, ஆக்சுவலா நம்ம கியர் மாதிரியே ஒரு மத்து இருக்கும். அதுல என்ன நடக்கும் அப்படின்னா, when they are sprinkling it, the collision which is happening or the disturbance which is happening will be more. அதே மாதிரி தான் இங்க இருக்க நடக்கும். ஏன்னா இங்க வந்து it is going to revolve the material and sediment. Again there is two things which is going to have major impact with your tool profile. If you use retrading side welding, like advancing side retrading side அப்படிங்கறத உங்களுக்கு சொல்லலாம். I should have told you in the first slide. Advancing side retrading side, there is one more concept in this FSW. And the advancing side retrading side அப்படி என்னன்னு பாத்தீங்கன்னா, if there is a tool which is plunged and which is rolling in this particular direction, then this is advancing side, and the other side opposite to the rotation is called as retrading side. If the tool is rotating in this direction, it is advancing side. Ipo you should be very careful in making this tool profile, this thread formation. The thread formation எப்படி இருக்கணும்னா, when it is rotating, the thread should not pull the material, rather it should push the material. That is, it should suppress the material rather than pulling it off. Pull பண்ணிட்டா என்ன ஆகும்னா, மெட்டீரியல்லாம் வெளியில வந்துரும். You will have a கீழே பாத்தீங்கன்னா you will have some defect like tunnel defect at the bottom, where the rest of the things will be there. This is majorly because you have made a wrong threaded side, where instead of pushing the material down, it pulls the material. அப்புறம் இந்த இதெல்லாம் பாத்தீங்கன்னா mostly this everything will be created in order to push the material down, so that you will get lot of input in getting it down. So apart from this, like the TWA, the Welding Institute, அவங்க டெவலப் பண்ண நிறைய டூல்ஸ் அப்படின்னு பாத்தீங்கன்னா, this is tri-fluted, which is said to be the most promising tool in FSW process. And here you can see a double pass for 100 mm. Sorry, just put it, yeah. Double pass for 100 mm. So single pass, it is capable of producing 50 mm over single pass. And in the ratio there is a ratio which can be maintained, where your shoulder should be around 3 times that of your tool. That is, if your tool diameter is 6 mm, your shoulders should be around 18 mm. This is the basic thumb rule which is to be followed in any of the manufacturing FSW tools, right? So அதுக்கப்புறம் இந்த skew angle, like we started producing, ஏன்னா இப்படி பண்றதுக்கு இப்படி பண்ணோம்னா the eccentricity, it is again going to have lot of collision which is going to happen. There is again advantage as well as disadvantage because of the packing nature which is to be done. So in the aspect line we can go on tool proportion. So as I said, like tri-fluted is the maximum thing, but நமக்கு வந்து we maximum work on maximum of 12 mm plates தான் நம்ம வந்து maximum we'll go for 6 or 4 mm or 8 mm, maximum 10 mm. அது மட்டும் தான் நம்ம FSW பண்ண போறோம். So cylindrical threaded is more than sufficient for our working nature of the tool, like research whatever we are doing. Alright, இதுல இன்னொன்னு பாத்தீங்கன்னா, you should understand the basic about this particular process on metal flow phenomena. What is the metal flow phenomena அப்படின்னு கேட்டீங்கன்னா, there are two types of metal flow in this particular process, where you have a basic first mode of metal transfer and second mode of metal transfer. The first mode of metal transfer is completely done with your shoulder, and second mode is complete with your tool. So there you will have a tool locking mechanism. Like the first mode will be completely having a revolved profile where all the material are getting revolved, and the second mode of metal transfer will be completely on compaction nature, where the material which is getting skewed in are getting compacted and it makes a flat profile. This is how your first mode and second mode differs. So your first mode is all about that takes place by tool shoulder, like what you have at the top, and your second mode is what you have in your downside, that is completely with your tool. So first mode and second mode of metal transfer is also a phenomena where you can work on few research aspects. So இங்க பாத்தீங்கன்னா the first mode is of something like this. இங்க second mode பாத்தீங்கன்னா you will have materials over here, இது மாதிரி இருக்கும். So your second mode will be something like this, where all your materials are skewed or rolled around, and first mode will be flat profile where it will be completely compacted by the action of your shoulder. அதுதான் வந்து it is going to give you your first mode of metal transfer, and this tool profile is completely responsible for creating your second mode of metal transfer. To understand this, அதுல தான் வந்து the better efficiency can be obtained with your onion ring formation. Onion ring formation is also going to give a better impact on this. If you are getting a better onion ring profile, then your complete profile is said to be best on its own because of this particular welding process. So to identify this, like we are quite crazy in getting things. This was a trial done by our professor Dr. Smuthukumaran from NIT Trichy. He was explaining us this particular criteria based on this first mode and second mode oda difference eppadi irukum in the onion ring formation enna agudhu. So it is like it is rolling of material ulla வந்து roll ஆயிட்டே போகுது. So இதோட cross section தான் நம்ம பார்க்க போறோம். So whatever you see here, this is what is represented over here. இங்க ஃபார்ம் ஆகுற onion ring தான் வந்து இங்க வந்து இப்படி visualize ஆகுது in cross section. Right, again we did something on this fractional analysis, like where first mode and second mode வந்து we introduced some MATLAB design with some coding on machine vision use பண்ணி பண்ணோம் அப்படின்னா now people are doing with machine learning. It was machine vision earlier, now it is machine learning to predict what are the feasibility that can be obtained from this particular process. Right, now moving on with that is all about the how the process can be optimized or utilized if you want to do any research on things. And I think I would have clearly given you what are the places where we'll make some defects, like how to make a thread profile, how to make a profile, how to eliminate your defects. Those are the things which was given to you completely for your research to start up with your research. Okay, now I'll be explaining about what was my research and what was the journey I was handling out. Like my clear objective was to weld A2219. I was saying that, right, it is said to be the non-weldable aluminum alloy which has better mechanical property from -250 to 260 degrees Celsius. Liquid to brittle to ductile transaction அப்படின்னு சொல்லுவாங்க. What is that brittle to ductile transaction is when the temperature is changing on a particular environment, the material will lose its property. அதுல இருக்க material property மாறையில என்ன ஆகும் அப்படின்னா the plastic formation will be, that is ductile form, ductility of the material will be converted into brittle nature because of the sub-zero temperature. So this complete thing we were working on cryogenic fuel tank vending. In cryogenic fuel tanks, the liquid nitrogen or liquid hydrogen that is maintained at -183 degrees Celsius. அப்போ என்ன ஆகும்னா obviously if you go for other steel structure, the ductile to brittle transaction நடந்துருச்சுன்னா அப்படி ஆகும் அப்படின்னா the steel will turn like a glass. ஒரு சின்ன கல் எடுத்து அடிச்சீங்கனாலே உடைஞ்சிரும். That will become that much brittle. So அதுக்கு you should have a particular material which can sustain in varying environment, either it is 260 degree or -250 degree, the materials is sustained without any mechanical failure, so that when it is going on to space it is not going to have any problem. Appoda we have started with this, working on this A2219. This is a prior process, and how we were associated with this row is like earlier this particular welding was done with TIG welding process where they were getting only 40% of the efficiency because aluminum TIG is possible only with AC welding. So where they had only 40% of the LD efficiency, but our prior focus is to increase it at least to 80 to 95. But we were not that much. Their expectation and reality, there is two things, right? So A219 we were able to get around 75% efficiency, and dissimilar welding of A2219 2014. This dissimilar 2G's compression, we were able to get around 88% efficiency. I'll just explain you how we achieved that particular level, right? So obviously we were doing lot of trials in optimizing the process, and we fixed this tilt angle to be 3 degree. We don't want to change load to be stagnant 12 to 15. We didn't change anything. It was auto generator load because we kept it as position control. So we were majorly focusing on rotation speed, welding speed, and tool profile. We were focusing only on this to get our product output. And before getting the actual welding process design, we were working on different sequence how this can be actually optimized. Then we come to a particular loop like accuracy and precision marda. We were doing a lot of trials from 500 to 2000 rpm, then 100 to 500 rpm, and we found this particular range is far better. Like we eliminated few stages and we consigned to this particular domain and compared with these three profiles, like in that profile வந்து better இருக்கு because people were addressed cylinder tool நல்லா இருக்கு அப்படின்ட்டு, people few have addressed taper நல்லா இருக்கு அப்படின்ட்டு, few have addressed shoulder and taper threaded, both shoulder and taper if it is threaded, like that is giving much yield அப்படின்ட்டு. But we have to try it actually what is happening. So அடிச்சிட்டோம், belt அடிச்சிட்டோம், we have got some better parameters. Then how to improve it? Like once your welding is done, you are getting a perfect welding without any defect, right? Is that fine? Can you summarize your process with that? No. You have to further make optimization in this. How to optimize in welding sequences? You should know what is the behavior of the material by doing mechanical characterization or material characterization. அதுக்கப்புறம் என்ன பண்ணிட்டோம், we started going with this. Like we started bisecting the material, we have tested with tensile specimen were tested. After that we were going for cross sectional analysis. என்ன மெட்டீரியல் இருக்கு, எதனால வந்து இதுல வந்து we are not able to achieve 90% or 80%, why it is only 75%. இங்க பார்க்கையில what we found is, this is the onion structure what we obtained in our process. So இங்க பாத்தீங்க அப்படின்னா the closer profile where you have closer mean quite finer grains, இங்க கீழ போக போக பாத்தீங்கன்னா due to this centrifugal force and allowing of medical to be mean crystal to be formed finer and finer, கீழ போக போக வந்து it was found to be very finer. The coarse mean grains were found to be very finer. But other side la pathina, this is like advancing side where there is a pull effect which is happening. So material are getting pulled and there here the material are getting sedimented. So in the pull and push grain we are seen over here in the இடத்துல பாத்தீங்கன்னா. So இங்க வந்து மெட்டீரியல் வந்தோட சைஸ் வந்து டிஃபர் ஆச்சு. ஓகே, இதுல வந்து நம்மளால வந்து மைக்ரோ ஸ்ட்ரக்சரை வச்சு we are not able to predict what is the actual defect which is happening in this process. Then we went for the SEM analysis. All right, SEM analysis la enna we found or observed is there are ductile crystal and brittle crystal, like slide tear is obtained and pull or ductile dimples are also obtained. Ductile dimples இந்த ரீஜனுக்குலாம் dimples அப்படின்னு சொல்லுவாங்க. அப்படின்னா ஒரு அதை பிடிச்சி இழுக்கையில there is a void which is being created. அந்த void வந்து ஒரு குட்டி void வந்து formation இஸ்க்கு dimpleமாங்க. இன்னொரு சைடு பாத்தீங்கன்னா this is completely behaving ductile and this is completely behaving brittle. Brittle side எப்படி பாத்தீங்கன்னா there will not be elastic limit. This is completely on brittle nature where நம்ம பென்சிலை சாப்பீஸ் உடைக்கிற மாதிரி தான் டக்குன்னு அப்படியே புட்டுட்டு போயிடும். ஸோ லைக் கிளாஸ் வாட் எவர் இஸ் கெட்டிங் broken, லைக் வென் யூ டெஸ்ட் யுவர் மெட்டீரியல் இட் வில் elongate and break, பட் வென் யூ டெஸ்ட் யுவர் கிளாஸ் தி elongation is 0, it is completely brittle. அது மாதிரி ஒரு சைடு வந்து பிரிட்டிலும் ஒரு சைடு டக்டைல், தட் இஸ் மிக்ஸ்டு மோட் ஆஃப் transition was happening in the process, right? Okay, இப்போ இதுல வந்து இதுலயும் நமக்கு தெரியல. ஓகே, செம் எடுத்தாச்சு, அதுலயும் பாக்குறோம், செம்ல வந்து பாக்கையில வந்து பெருசா ஒன்னும் தெரியல. ஓகே, வாட் வில் டூ ஃபர்தர், ரைட்? இதுல பாத்தீங்க அப்படின்னா ஒரு குறிப்பிட்ட ரேஞ்சில இது பண்ணிருக்கோம். தென் we were not able to identify what is happening with this. Okay, failure zoneல பெருசா ஒன்னும் இல்ல. Then again we went for some cross section, like fracture zoneல வந்து we started investigating what is going on. Further we investigated. அப்பதான் we found there are a lot of craters or vent holes which is being generated. அங்க பாத்தீங்க அப்படின்னா the scale is 5 microns, the scale is just 10 microns. இது பெருசா ஒண்ணும் இல்ல, but our void was like more than 10 microns. இப்போ இதையும் கம்பேர் பண்ணி பாத்தீங்கன்னா our void was more than 10 microns. Hey, come on man, your crystal size is not more than 7 to 10 micrometer, but you have a 10 micrometer void which is created within your process. இதுல ரெண்டு விஷயம் இருக்கும். ஒன்னு, your process is not that sufficient or that good in order to get complete packing, but that is not possible. ஏன்னா வந்து நம்ம வந்து we have gone for testing, There was no actual defect in the and the tunnel defect or எதுவும் இல்ல. Then we went for RT or UT, radiography testing and ultrasonic testing. Both were found there is no defect in the welding process, right? இதில் எதுவுமே தெரியல. So when we go for this, we found there is something which is some crater which is being generated in the welding sequence that is being the major source of failure. So அப்போ வந்து இந்த ப்ராசஸை நம்ம வந்து எப்படி ரெக்டிஃபை பண்றது? We were just brainstorming like how to do all this process. Luckily we came to know that the major composition of this is completely copper. All right. எப்படி சார் இங்க காப்பர் வந்து உள்ள வந்து செடிமெண்ட் ஆச்சு, ரைட்? இதுல வந்து அரௌண்ட் 6% காப்பர் இருக்கும். அலுமினியம் காப்பர் அலாய் வந்து இட்ஸ் அலுமினியம் காப்பர் அலாய் where you have around 6% of copper throughout the process. Due to the centrifugal force which is being created, the saturated coppers are started getting accumulated or agglomerated in a particular point. And the weight ratio vary again. The copper will be quite more higher than the aluminum process. When it's getting heated and refined, what is happening is that particular portion of copper which is being spread over there or getting started accumulating in a particular place and getting in a particular place. இது எப்படி இருக்குன்னா நம்ம when you have a complete crystal, when there is a small dent or something and the இடத்துல மட்டும் breakage நடக்கும்ல, there is no proper bonding. It is like rest all the material are similar, there is one inclusion which is or inorganic foreign bodies which is getting entrapped in the material, and the இடத்துல மட்டும் you will not have enough bonding between the material. And the இடத்துல what is happening is it is creating a crater because of the accumulation of the copper which don't have which has only partial connection, which is not having better connectivity with the aluminum, that is making a small loop over there. And the இடத்துல failure is to be maximized. அப்போ the only aspect is to disperse this copper which is getting accumulated or agglomerated in a particular point. Okay sir, இப்போ வந்து ரீசன் கண்டுபிடிச்சாச்சு. We have done welding, everything was good, but still we are not able to attain the what is the maximum efficiency in the process. And now we found which is the who is the culprit making all this sequence go in a wrong way, because we want something around 85 to 90%, but this guy is giving only around 75 to 80%, 75 to 77% of the field, where we don't have complete insight with this or prediction is something or achievement is something. And we found this particular copper which is creating all the steps in the process, right? Now இப்போ நம்மளோட அடுத்த task அப்படின்னா how to rectify this particular defect which is happening in this process. How to rectify அப்படின்னு யோசிக்கல. Again, we don't have any other option. Only thing is this is getting agglomerated due to the rolling action which is happening with the tool. Okay, only thing what we have to do with the tool is இப்போ நம்ம மோர் கடையில என்ன ஆகும் அப்படின்னா நல்லா கடைஞ்சோம் அப்படின்னா it will get dispersed and come out. பட் நம்ம குட்டி ப்ரொஃபைல் மாறையில என்ன ஆகும் அப்படின்னா அந்த குட்டி இடத்துல மட்டும்தான் it will wrinkle off and it will generate. அதே விஷயம் தான் we were applying over here. இங்க என்ன ஆச்சு அப்படின்னா the profile whatever it was created is not that good in order to split the copper precipitate or disperse the copper precipitate uniformly. So we started introducing a flute like chinna flute like pulsed mode we started introducing. So earlier the tool profile was continuous, so it was going on a continuous process. Then what we did is in this particular tool over the string we introduced a flute like ஒரு சின்ன கட் இது பண்ணிட்டோம். அப்ப என்ன ஆகும் அப்படின்னா it will create a pulsating action where it is not a continuous flow, it is going to be a pulsed flow. Each and every flow is getting interrupted like அப்படிங்கிறதுக்குள்ள ஒரு 10 பல்ஸ் கிரியேட் ஆயிரும் due to rotation. அப்படிங்கிறதுக்குள்ள ஒரு 10 பல்ஸ். It is like cut sediment. Earlier it was cut sediment, it goes on rolling. It was cutting, rolling. But now due to the this flute which is created, இங்க என்ன ஆச்சுன்னா இந்த கட் வந்து இங்க நின்றுது. ஏன்னா there is no connectivity. மறுபடியும் அடுத்த கட் flow. So layer by layer ஜாயின் ஆக ஆரம்பிச்சிருச்சு and dispersion was too good. இதுல வந்து we were not able to get a better efficiency like around இதுதான் இவ்வளவுதான் எங்களால எடுக்க முடிஞ்சுச்சு. Around 75% of the parent material strength was able to apply. Then we tried adapting that particular process on dissimilar welding of. This was still more complicated because this is not same material. In the material at least stick welding la possible. This 2014 and 2024 there are two material which are called as structural element. It is completely impossible to weld with any of the process. Even TIG welding, it is not possible to weld this process. Okay, in the process வந்து we thought like ஏன்னா when you go for a higher complexity, you will get a better result rather than working on the same result for a period of time. So இதை எடுத்து பண்ணலாம் அப்படின்ட்டு பிளான் பண்ணியாச்சு. Okay, we'll go with this particular process. What is happening? So what we did is, after making this, you could see here a pulse generation is being done. இந்த இது முடிச்சதுக்கு அப்புறம் we were making some fruits over here. In the heat treatment எதுக்குன்னா, if someone is doing research, if you are not capable of I cannot say you are not capable of, if you are not able to produce like spend more amount for procuring tools, in the heat treatment method use பண்ணீங்கன்னா the total production cost of tool will be just 300 rupees, where your machining cost for this particular profile creation will be around say 150. Material charge will be around 70, and heat treatment, if you have, you can avoid that as well. In the heat treatment procedure use பண்ணீங்கன்னா you will get better toughness tool. The toughness of the tool will be far better. If suppose if you are using one tool for producing 10 welding right now, that is highly impossible in FSW because the breakage happens simultaneously. But in the tool use பண்ணீங்கன்னா, I can assure you will get at least 10 to 15 welding. So this tempering process we used for D5 tool steel. This was capable of going till 7 series aluminum alloy. 7075 even we welded with this. This was perfect, right? So இதுல வந்து we found like okay, அங்க பார்த்தோம் அப்படின்னா the profile was too good. அங்க பாத்தீங்கன்னா better finish வந்துச்சு, better surface level வந்துச்சு. பட் இங்க பார்க்கையில வந்து we were not getting, என்னடா அது கொஞ்சம் சென்டர் சும்மா, it is not getting proper profile. அங்க இங்க பாத்தீங்கன்னா சொரசொரன்னு இருக்கு. We thought like this is not that good as 2219. But we all go with the power, right? Beauty is dangerous. That was applicable over here also, which was beautiful, which was having a better finish at the surface, that was giving only 75% efficiency. This was not beautiful, like this was the finish was not that the finish was not that proper due to the mixing of two material. There it was only 2-to-1-9, a single material was being used. Here it is two material. The combination of two material were not giving that much impact over stress. So inge vandu the surface finish was not good. But luckily speaking, when we do all the characterization testing, it was found at the beginning, at the end, the crater which was around 10 mm, now it got completely reduced, like it got completely reduced, and the fine precipitate, fine segregation were there. Like எல்லா இடத்துலயும் பாத்தீங்கன்னா there were fine segregation, and the copper precipitates were completely done. அதுக்கப்புறம் finally we got from particular thing, we got around 40 mm increase in yield and 20 mm increase in yield strength and 40 mm in tensile strength, and the efficiency was around 88%, where earlier it was only 75%. So with these things, like on optimizing all this process, we were able to achieve almost 88% of the efficiency, which was our required process during that welding process. So now our efficiency was gradually increased from 40 to 88%, and now I'm very happy and proud to say this technique has been adopted by ISRO and validated and accepted. Now the joining of cryogenic fuel tanks, few of the fuel tanks, this technique is also getting incorporated in ISRO for manufacturing their fuel tanks, or joining their fuel tanks at the for getting it as a final output by increasing our efficiency from 40 to 88%, right? These are about the research what I worked on 2219 and 2014, like what are the difficulties we faced during the journey, how different aspects were handled in order to get a product specific output, right? So application, okay sir, இதுல வந்து நீங்க இஸ்ரோல பண்ணிருக்கீங்க, ரைட்டு, எங்கெங்கெல்லாம் அப்ளை பண்ணலாம் அப்படின்னு கேட்டீங்கன்னா, there's plenty of applications starting with aerospace, shipbuildings, structural fabrication. Of course, iMac in 2012 they used this particular technology for joining of the bottom plate and the top desktop with FSW process. They were joining using this particular technology to fuse both the process which were in aluminum pieces. So எல்லா இடத்துலயும் it got wide application. Of course, if you go for aerospace or this space capsules or trains or ships, everywhere it is having its own applications. The major application in aerospace was in Delta 2 and later Delta 4 rockets. இதுல தான் வந்து first NASA was implementing this particular technology for getting aerospace application using FSW process. Right now, around 40 to 55% of the welding of aerospace in NASA is only with this particular technology. They are not using any other technology. They are using only FSW technology for most of their welding components. So something like this process was later adapted for space shuttles. Then this bulkhead nose, which is to be at the edge of the rocket launches, that also was used by this process. This dome, whatever you have at the top, in the dome in the dome this particular portion was even welded by FSW process. Earlier it was by other welding process where there was not much efficiency, so they were increasing the thickness, but now with limited thickness they were able to achieve the better strength, so they have adapted this particular technology for joining of these components. And thirdly, like even this space capsule was being used or was utilizing this FSW process. So marine la pathina this particular thing where this is around 1 meter. This technology was also adapted with FSW process. Marine decks were also using this FSW process. Others, repair welding. Repair welding is a priormost thing where FSW can also be used. That gives to the rise of friction stir processing where it deals with surface, and that I'll discuss. இப்போ நம்ம normal fusion welding process we got some defect, blowhole or something. Instead of throwing that welding or reworking on that welding, if you go for FSW over that particular welded zone, in the weld zone மேல FSW பண்ணீங்க அப்படின்னா it will reframe your defects and you will get a better weld strength over there. So that is also possible right now. All right, this is completely about friction stir welding. Other technology, what are the other technology available in this is friction stir spot welding, where mostly now Maruti, Hyundai are getting adapted to this. Instead of normal rest and spot welding, they started using this friction stir spot welding in their companies. So inge pathina Mazda RX-8 is there. In that rear door is completely, the aluminum panel is completely made by friction stir spot welding processes. இங்க இதுல பாத்தீங்கன்னா இங்க இருக்க ஸ்பாட் எல்லாமே friction stir spot welding வச்சு தான் பண்ணிருக்காங்க. So now companies are slowly getting adapted to this. And the first aircraft to be made, aircraft பொறுத்தவரையும் பாத்தீங்கன்னா if you have traveled in flight and the side wings பாத்தீங்கன்னா everything will be riveted. Everything will be riveted. There is no nut and bolt technique because it has to be rigid. And இது வந்து almost 7,300 fasteners were removed and replaced with 263 friction stir welding. Just 263 friction stir weld was used to replace around 7,300 fasteners in Eclipse 500 business jets. So this was again glow in this particular technology. Right, spot welding is over. அப்புறம் friction stir processing. Friction stir processing வந்து இந்த டெக்னாலஜி எதுக்கு அப்படின்னா to modify the surface. Say you have a soft material, நம்ம ஹேண்டே வந்து ஒரு இதுவா எடுத்துக்கலாம். It is the top layer is friction stir surfaced. அதுக்கு உள்ள போனோம் அப்படின்னா that layer is soft. அதாவது வெளியில நமக்கு ஹார்டா இருக்க ரீஜன், உள்ள போகையில நம்ம சதையெல்லாம் வந்து ரொம்ப சாஃப்டா தான் இருக்கும். they are more sensitive. சும்மா சின்ன இது பட்டாலும் நமக்கு வலிக்க ஆரம்பிச்சிடல. they are very soft. பட் இங்க பாத்தீங்கன்னா it is quite hard. This is the perfect example of friction stir processing where your internal material will be soft, though you are making your external material harder in order to sustain a particular job to be done or sustain the erosion, corrosion or wear behavior that is going to be the primemost task in this particular operation. Though your internal material property is different, your external material property or surface material property is altered in order to get a desired output. So that particular technology is called as friction stir processing, where your inner material remains soft, only your outer surface is making harder. This is most in many of the process. Even I worked on one particular technology for one of my friend. His name is also Dinesh. He's from Banari. We were what he was doing some projects. I don't want to name what the project is. He was working for doing a project for a company, and we were doing FSP on around 15 micron coated. Romba minute. It was like he has quoted something to improve the efficiency. Over that, he was proposing FSP process in order to improve the efficiency, and the process we are doing, it was quite interesting. So everywhere, like this FSP can be used in most of the applications where casting the defect இருந்துச்சுன்னா you don't want to rework it again, you don't want to throw it, melt it and reframe it. Instead you can go for this FSP or FSW process, where FSP, it can remodify the defect, like again like repair welding, it can be used for remodifying the defect in that particular sequence. And friction surfacing, இதுக்கு அதுக்கும் இதுக்கும் என்ன டிஃபரன்ஸ் அப்படின்னா, in friction stir processing you have a tool pin, but in surfacing you have only flat surface. FSP and friction surfacing, இதுல வெறும் flat surface தான் இருக்கும். It will just grind over the surface. அதுல வந்து ஒரு 2-3 லேயர் வரையும் it will alter, it will just grind over the surface. That is the difference between this. And one more technology available in FSW is tube to tube plate welding. This was patented by my guy Dr. Muthukumaran. Welding of plate and tube in a single FSW process. So this is the holistic arrangement what is being made, and based on that the top layer is getting fused to the pipe, and there will be a joint which is happening in this particular region. So tube to tube plate is also possible. And I have worked on this particular polymer welding also, like one of my senior was working on this on nylon 6/6 material. And again we adapted friction stir additive manufacturing process to get this, because like in the what we faced is when we are going for a welding, plastic then it was like plastic la vandu thenga thuruvi potta mari, it was getting a small droplet, so we were not able to get a perfect welding. Then we went for friction stir additive manufacturing technique to get a proper weld zone, which was giving around again 70 to 80% efficiency, where earlier it was only 24 to 26%. So we were able to achieve this as well in polymer welding processes. So this is like the thermogravimetry analysis what we did on this particular thing. Inge pathina the maximum heat is just 112 degree, sorry 30 112 இந்த பாயிண்ட்ல பாத்தீங்கன்னாவே அவ்வளவுதான் இருக்கும், மேக்ஸிமமே அந்த ரேஞ்ச் தான் ஃபாரன்ஹீட்ல. So around 30-35 layer and we were able to weld that plastic materials. Right. The final topic, I have just 4 more minutes left, so I'll try to complete this. Now we are working on this particular aluminum magnesium transition joint. இது எதுக்கு யூஸ் ஆகுது அப்படின்னா, எல்லா ஸ்ட்ரக்சரல் எலிமெண்ட்டும் it is not going to be stressed loaded. இந்த ஏரியாலாம் பாத்தீங்கன்னா it's completely less stressed. அப்ப அந்த ஏரியாக்கெல்லாம் you don't want aluminum, you can actually replace with magnesium in order to reduce the total weight. You know, the total weight reduction is the maximum process, and we proposed few process, like we adapted few process and we published around 2 journals in this particular technology as well, aluminum magnesium transition joint fabrication. And we are working on a project proposal also for getting this into reality. Eppadi magnesium can be replaced with aluminum, because in future you will not get maximum of aluminum, we have to replace most of the aluminum with magnesium. And it is a myth, people says that magnesium is highly explosive and it burns, it cracks. It will not happen. Even for engine, people are using now magnesium engines instead of aluminum. They have gone for magnesium engines where you have continuous sparks which is happening. Magnesium sparks only in it is in powder form, not in solid form. So that myth has to be eradicated from your mindset if you want to gradually move on from aluminum to magnesium, which is having a better scope in the market, right? So these are the other FSW machines available, and these are few of my references. And our recent research focus, we are working on some designing of ventilators, like sanitizing and automatic retrieval, like delivery as well as disposal unit on 3-play and 2-play masks. And few research on underwater welding, where I got my complete certification for human welding, and we have started exploring some parts in underwater welding as well. And few technology we have developed, like for new proposed tools, everything, and few other micro FSW for bobbin tool variety, where which were not even like whatever we have this support clamp structure. You don't want any support, you can directly go for welding with this bobbin tool variety, and this we are trying in micro rubber as well. And apart from that, we work on few design on additive manufacturing. This is what a small design made in our laboratory, and we were using this during COVID time, and we were even giving to our particular our staffs for using this as a clamp when there was scarcity in Amazon or local shops. We were not able to get everything, and the people were having too many impact on this. So we were creating this as well that time. So this is all about my lecture. If you have any doubt, you can ask in that.
Thank you, sirs.
Thank you.
Dear participants, any interaction?
Very useful presentation. Thank you. Any queries? Thank you, Nagarajan sir. Thank you. Any other queries? Learned a lot, sir. Thank you. Feedback link. Cool. I think like if there is no queries, I'll just give you a glimpse of what is Kashmir is. So if you are coming in future, I can even host you. I'll be happy to host you. About Kashmir, this is what is Tulip Garden, what we have. Like all these are what I explored. If you want to visit Kashmir, the better time would be March to April, where you can witness everything. This is complete tulip garden what we have, and this is the snowfall what we get during March even. December it will be too peak where we'll go in minus degree, around minus 10 degrees Celsius. So it's like something abroad. It's completely full of snows, and of course this is the lake what we have behind, like where we have floating market stuffs, everything. And we have few gardens where we can have explore better time, and this is the aerial view of Kashmir. When you travel to Kashmir, you can experience lot of things like that. And if you have any further queries for anything, you can always free to contact me at any time to either my mail ID, or of course like if I'm not responding, you can put a text. I will respond after some time. Like if I'm not able to take a call, like whatever I got called right now, like I may be able to respond after time. If you have any other further queries, anything regarding welding or additive or optimization, I'll be happy to help at any cost. Thank you.
Thank you, Professor, for your wonderful session and amazing presentation in the topic of friction stir welding. It was very much useful for emerging researchers and faculties across the nation. Even though your busy schedule, you have delivered a wonderful session, sir. Once again, thank you, sir.
Thank you. Nandri, thanks for the
Okay,
opportunity.
sir. Nandri, sir.
Shall I leave?
Yes, sir.
Thank you. Thank you, sir.
Thank you, sir.